Alright, I used to have my students draw. If you want to try drawing your rhombus, your rhombus, you can. However, even my rhombus was not a great rhombus, so I just figured it was easier to print them. That way we know what a rhombus really looks like. Okay? So, we're going to say a rhombus is... So a rhombus, because it's a singular rhombus, is a parallelogram with, and I'm writing this kind of parallel, silly because we're going to put a picture right here. So parallelogram with, and we're going to make a list. Okay, so you can go ahead. We're going to glue these in kind of all separately. So if you want to cut these all apart right now, you can. You should have 4 different parts, but you are going to glue them in separately, so do not glue them all in yet. We're going to start with this bigger rhombus, and we are going to glue it in right here, so it's next to our drawing. So go ahead and glue in that big ABCD one. It has the middle point of P. Alright, so something we know about a parallelogram, or I'm sorry, about a rhombus, it's a type of parallelogram. Again, it's similar to how your pointer finger is a type of finger. Are all your fingers exactly like a pointer finger? No. But are all pointer fingers a finger? Yeah, crazy, right? Okay, so a rhombus is a parallelogram, so it looks similar to that parallelogram, that slanted kind of rectangle. Okay? So things that we know still is we know that angle A is congruent to angle C, angle D will be congruent to angle B, opposite sides are congruent. Okay? What we do know about a rhombus is that all sides are congruent.
What's that word we can use when we know all the sides are congruent? What would we call that?
What are you talking about? Oh, yeah. Whoa, look at you using your academic language.
Doesn't that equal prefix equal what? When the sides
I did not have that in my notes. Good addition. So I'm going to mark those as congruent. I'm going to use those tick marks saying they're all the same. Okay, a rhombus also has perpendicular diagonals.
break that apart. Perpendicular.
That would help if I spelled it right.
So that's going to ask you to remember two kind of important words. What does perpendicular mean? Not parallel, it's perpendicular. What does that tell us? Then the line of it back, super smart. Remember, parallel runs side by side. What about perpendicular?
They intersect. Good. They intersect at.
What? Yeah, they intersect at the same point. And what type of angle do they make? What degrees is that angle that they have to make? 90 degrees. You got it. And how about a diagonal? I thought we might have to review a little bit. Yeah, Michael's kind of drawn a line across.
So here, what segments are our diagonals from what point to what point? Start at A. A to where is going to be a diagonal? A to B, A to C, or A to D? Good. A to C is a diagonal. What's the other diagonal? Oh, you guys are just the smartest. B to D. You guys like to pretend you're not smart, but you really are. And that's 90 degrees. So what marking can we use for 90 degrees? So where those two intersect at that point P, all those angles by point P are going to be 90 degrees. Okay, and the last thing that we know about rhombi, or a rhombus, is that the diagonals bisect the angles. So what does that word bisect mean again? What does bisect mean?
Cut them in half. Yep, or split them into two parts that are equal. So those diagonals, that was the red line, bisect, they cut that angle in half.
So if we look at angle B is being cut in half by that diagonal. So I know that this side is going to be congruent to the other side. But remember, B was really the same as what other angle? D, yeah. So if those are the same, what other ones are also going to be the same? ADP is going to be the same as CDP. So all four of those angles are congruent to each other.
And then we can do the same thing with that other perpendicular diagonal.
All right, so those are three big things about rhombi that are different than what we've dealt with before. Okay, is that all sides are congruent, the diagonals are perpendicular to each other, and the diagonals bisect the angles. So those are really our three big new concepts today. So we're going to go ahead and take this guy here. And we're going to glue them in. I'm going to glue them in over here. You could glue them in over here if you want. You could glue it in the center if you really want to. I'm going to glue it on the left side, though. All right, we're going to do a couple examples using this as our rhombus to look at. So between the examples, it might change kind of what distances are, but we're going to look back at this one for our points and where we're going to get our points from. Okay? I'll give you a couple, 30 more seconds to get that glued in if you haven't done that yet. There's still a couple of us. If you're done and you have 30 seconds, cut your other two in half so you have those ready if you need to. All right, so for number 1, if dk equals 7 centimeters, then MD equals question mark. Right, so in our drawing there, or in our diagram, we have dk is 7. That's what we're given, is this one going across is 7. We're going to try and find out what is MD. And we know that this is a rhombus. So what is MD going to equal? Great, why? Good. A rhombus is equilateral, so all the sides are congruent. So if one side is 7, they're all 7. Number 2. If MK equals 16 feet, then dA equals question mark. So that's the problem. We're given that MK is 16 feet. Like I said, it's kind of like a refresh. We're not doing the 7 anymore. That's done, out of our brains. Okay, MK is 16. What is dA going to be? How do you know? Good. That A is a midpoint. Now, did we know that our diagonals are congruent, that M to K is congruent to D to L? Do we know that those diagonals are the same? Yeah, because that's not part of those parallelograms, right? Okay, so D to A is going to be half of that 16, right? No, that's wrong. No, erase that. We don't know that they're congruent. We only know that if it's a rectangle. That's a rectangle theorem. So parallelogram theorem means that we can cut it in half, but just for that, by that diagonal. Only a rectangle do we know that that diagonal is congruent to that diagonal. So we weren't going to be able to find dA. That was a mistake. Yikes. Should probably check that on your practice work before I send it out. Yeet. All right, so what is MA going to be? 8. Yep, because A is that midpoint. All right, number 3. Last one on this one, and then we're going to glue in the next, and then we just have one little thing about squares that we just need to know. If, now we're going to use that M, but this is a lowercase m because it's measure of angle LKA equals 36 degrees, then the measure of angle KDM equals what? So which angle are we given here with LKA? Where is that located? Good, top right. So LKA, we're looking at this angle here. So we're saying that that's 36 degrees. And we're trying to find KDM. So this whole angle over here. So what else do we know if that's 36 degrees? What other information can we decide? Yikes. Are there any other angles we know? What? You know that this bottom one is going to be 36? Yeah, you know this one's 36 and this one and that one, right? They're all 36.
But start filling in anything else we might know. What other angles or sides do we know?
There's a couple ways we can go about this. Either we can kind of think about it as triangles with those diagonals, or we can go back to thinking about it as a parallelogram. Do you guys want to break this apart and think about it as one triangle out of the four, or do you guys want to think about it as a whole parallelogram? A whole parallelogram? Okay, so if we think about this as a whole parallelogram, that's MDKL. What is the whole angle of angle K? How would we find that whole angle? So if this is 72 degrees, how are we going to find the angle that is next to it? How do we find that consecutive angle?
How do you do that? Good. He knows that those would add up to 180. So he did 180 minus 72. And what did he get? 180.
Now, is that the angle that we were looking for with KDM? Were we looking for that whole big angle? Yep. So that's our answer. The measure of angle KDM equals.
Did anyone look at this and think of it in a different way before you even got started? Like right away in my brain, I didn't think of the parallelogram. I thought of those as triangles. And if I know that this, let's say this angle here is 36, what other angle in this triangle do we know? Yeah, I know that those bisected, so that makes that 90, those are perpendicular. So I could know the whole thing is going to be 180 minus 90 minus 36, and I'm left with just this little part. I'm not quite done, right? Because then I'd have to double it to get to that whole angle. Either way, it could be fine, whatever your brain wants you to do. Sometimes when you're stuck, when you're sitting there staring at it, it helps you to start filling in things you know, and then see what information you can find from there.
Those are rock stars. Crushing it. All right, glue in that other parallelogram with all those numbers on it. 1, 2, 3, 4. We're just going to find those other angles. So if you want to try and work ahead a little bit, our goal for this one is we want to find out what is all of the angles equal to. What is measure of angle 1? What is the measure of angle 2? Measure of angle 3? And measure of angle 4. So if you want to try and work ahead of on this, after you glue that in, you can go ahead and get started. You have enough information to try that out. So give you a little time to get that written down. And then if you want to try and work ahead, start with pieces you know. You don't have to go in order of 1, 2, 3, 4. You can start with any of the angles that you know to start with. If you're trying to crunch this all into one page, it's okay to go over. Tomorrow we're going to be putting something in at the bottom of these notes. We're going to be pasting in a big table. So it's okay to be at the end of your page or to start a new page if you're like wanting really to stay all in one. All right, so what information are we given in this one? Yeah, Clade, what are we given? Yeah, we know that this angle here is 32 degrees. Okay, that's the only information that we are given, and we know it's a rhombus. So what other angle, which one do you guys want to find next after knowing 32? You want to find angle 2? Could find one. Is there any other ones that are a little bit easier right off the bat to know? 4. What's angle 4 going to be? What do we know about those bisectors, or those diagonals? Did somebody say it? Because I missed it. If somebody did. Oh. I don't know. It's 90. I don't know. My brain. Okay. Are there any other ones we know right off the bat without having to do too much math? What do we know is congruent to the 32? The one above is congruent to the one below. What other angles are congruent to these ones? Yeah, cross, opposite. So the C and the one below C. So now we know the measure of angle 3. What's the measure of angle 3? 32. What are we going to know about angle 1 and angle 2, though? They're congruent. So whatever we get for one of them, we know it's the other one. So there's a couple ways we can think about this. We could go back to how Miss Sawyer thought about it and think about this as a triangle. We have 32, 90, and then some number, and those have to add up to what? 180. We could find the whole angle of angle A, and then find the whole angle of angle B, but then split that into 2. Do you guys want to think about it as a parallelogram where you find whole angles, or do you want to focus in on just that triangle? Or do you just want to shout out the answer? What do you guys, which way do you like to think about it? Do you get the triangle or the whole thing? The whole thing. All right, if you think about it as a whole thing, what is 32 and 32 together going to be? 64. So 64 plus what is 180? Or what's 180 minus 64? $116? Okay. But now for 1 and 2, that's split down the middle. So if I take 116 and I have to split it into 2, 58. You can set there. Thanks. Okay, that's one way to do it. Another way we could have done is we could have done 180 degrees of the triangle minus 32 minus 90. And we should get the same answer. Either way, we would get that 58, and we know that those are congruent. All right, last little piece, real quick, is the square. There's nothing too exciting about a square. So go ahead and glue in the square if you haven't glued in the square yet. I'm going to be on the next page, so make sure you get that stuff written down. Alright, with the square, I'm going on the next page. You are going to have to glue something in tomorrow with this, so it's okay if you take up a whole nother page for this, because we'll have another thing to glue in. We don't spend too much time on squares because we are pretty familiar with squares, and there's no like special theorems about squares that we didn't already know. What's something that we already know about squares?
All four sides are equal. What else? All four angles are equal. So if we want to sound super fancy, how do these sides split? They are equilateral and...
Which means if they're both, what kind of polygon is this?
They're equilateral and triangular. Whatever. You're looking back at your notes that we first the introduction to chapter 6. Yeah, you got it. Or regular, yep.
Okay, and everything that's applied to rhombi, anything that's applied to a parallelogram, anything from a rectangle, anything from rectangle, parallelogram, and rhombi. Yeah. Anything from those, we can say is the same thing for this. So if we drew in those diagonals, the diagonals would cross at 90 degrees. Opposite angles are congruent. Consecutive angles add up to 180. Anything like that. If we have where the diagonals cross is going to be a midpoint. All of that goodness. And that's what we know about squares. And we are really not going to do a lot of problems with squares. We just wanted to keep that in there so that we know that it's still quadrilateral. It's just regular, meaning all four sides are equal and all four angles are equal. All right, when you come back from lunch, you'll have a quick practice. Otherwise, have a good lunch. It's going to take a day, but